Now we are going to let me. Now we've treated the mean deviation, and now we want to talk about the mean deviation where the frequency data is given. The one we treated before was mean deviation where the frequency data is not given. Now let's go to where the frequency data is given. Now let's go. Now this is where the data is given. That's going by what we have written before, our data that was given. Okay, that was given on going by the data that was given on 14, 9. That's 14, 9, 16, 10, 20, and 15, These are the data. Now the frequency is given. Now, well, first of all, what the first thing to do is to draw the table. Okay, draw the table. Now we have our table here, which is in 2 rows and 1, 2, 3, 4, 5, 6 columns. 6 columns. That consists of the 6 that we have. Now, this is ages in X. That's in numbers. That X connotes or describes the numbers. What are the numbers? We have 14, we have 15, we have 16, we have 18, we have 20. You go to within the range, okay? That's how it works now, okay? Now, the point is that frequency, how many? In 14, we have 6. 15, we have 7. That's how they appeared, okay? Take it to be like that. 16, they appeared 2 times, okay? Then 18 appeared 3 times. We are used to what we call a frequency now. Now, 20 appeared 2 times simultaneously with 16, right? Okay. Now, with that frequency distribution, let's take it's an example now. Frequency distribution of students in a class of a given data, of a given school, so to say, a given school like in Kogi State or so. Now, this is the first step. Let's see, this is the first step now. What is the first step? Because this is the mean deviation where the frequency data is given. So the first step, you find what is the mean. The mean, which this is mean, is equal to sum of the frequency times the number or the values all over the sum of the frequencies, which is equal to 14. 14 appears how many times? 6 times. You see? The frequency now appears 6 times the 6. It appears how many? 6. Now, that based on the summation, based on the formula. Okay? This is the formula here. Sum of the frequency times the number. That you multiply this by this. Okay? By the 6. That's what we have here. 4 by 6. That's bracket, open and close, plus bracket, open and close, 15. The next one is 15. It appears how many? That's times 2 again. Then plus 16 times 2 again. Then you have 18 times 3. Then 20 times 2. Okay? 15, 7 rather. Now, that's 15 appear 7 times. Okay? 7 times. Now, all over 6, all over what? The formula says all over the summation. The summation. Remember, sum of, either in our last this we talk about this sum, this sign. Either summation or sum. Sum of. Summation of frequencies. Where are the frequencies? 6. That we have them. 6 here, 7 here, 2 here, 3 here, 2 here. Now simultaneously, now we have 6 plus 7 plus 2 plus 3 plus 2. Therefore, it's about 315 all over 20. Therefore, the mean deviation, the arithmetic mean rather, this is the sign of arithmetic mean, not mean division. Mean division is empty. Now, arithmetic mean is equal to 250 all over 20. It gives us about 15.75 mean deviation. Mean deviation there, therefore, is equal to 15.7. That's what we're talking now. Now, this is okay. Now, mean deviation, therefore, is equal to that. The position is about. See, it's about summation of the frequency into number minus arithmetic mean. That is it. That's the mean deviation. Now, let's go to plot our table fast. Very fast. Very fast. Let's plot our table now. Step 2. We are going to step 2 right now, so that we can just get the whole thing and get away with what we have. We are doing with the mean deviation as a whole. The one where the frequency data is given, or it's not given rather. That's the first one. Then the second is the one where the frequency data is given, and we have plotted our table and we extracted those frequencies, multiply. We have done all the summation, apply the formula, and they are now working perfectly for us. And as we go on, we plot the table and go. Now, these are the table right now. Plot it, and we plot it. Okay? This is how the table is being plotted. Now we have 1, 2, 3, 4, 5, 1, 2, 3, 4. We have 1, 1, 1. We have 1, 2. We have 1. We have 2. We have 3. We have 4. Now, let's see. Now we have the row. We have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 2, 3, 4, 5, 6. Okay. Okay. Now we are going. Now we have edges in. Now we have frequency in X. Then we have number minus the arithmetic mean. Then we have f x minus arithmetic mean. Okay, edges. Sorry, that's frequency rather. Frequency. Okay, that's frequency. Now you have frequency. Now we have the frequency. That's frequency. We have F frequency, X. Then you have X, that's number minus arithmetic mean. Then you have frequency, that's number into that's arithmetic mean. Now, here we have 14, we have 15, we have 16, we have 18, we have 20, have frequency. I have frequency. Sorry, sum of frequency is equals to 20. Then sum of x is equals to 3, 1, 5. 4.25, and that's then the last one you have sum of frequencies all over x minus mean deviation minus mean deviation, which is equals to 31.5. Now, here we have 6 frequency. You have 6, you have 7, you have 2, you have 3, you have 2. Then under the frequency that multiply that, you have 64, you have 105, you have 32, you have 54, then you have 40. Under number or variable minus mean deviation, you have 1.75. Then you have 0.75. You have 0.25. Then you have 2.25. Then you have 4.25. Then under the frequency times the variables, we have 10.5, 5.25, 0.50, 6.75, 0.75, then 8.50, 8.50. Now, this is just what we just plotted right now. The ages, okay? The ages in variables or numbers, the frequencies, connoted or indicated or given by f. Then frequency times the number, the variables. Then the values minus the mean deviation, that's the heading. Then frequency times the numbers minus the mean deviation. Why the number here is now? What you simply do is that you see all the headings now. The ages, 14 ages within 14. Okay? Now the frequency, how many? They appear 6. Then if you multiply them, you have 64. That you multiply this frequency, you multiply this by 14. It gives you 64. Okay? Then if you subtract this x, that's the numbers here. You subtract mean deviation from the value. For the value here, it gives you 1.75. Do your calculation. This is x. You just substitute from x here. You put the values here. Put the value. You subtract mean deviation. What you had there, you put it. It gives you 1.75. Then the frequency. If you multiply frequency by the number, you subtract mean deviation from it. After you multiply, it gives you 0.5. Do your calculation. Now the ages of 15, and so on and so forth. The ages of 15, you You apply the same principle. You multiply this 15 by this. Multiply it by 7. Do your calculation. If you multiply this 15, okay, you go by the rules. If you multiply this 15 by 7, what are they saying? They say multiply the frequency by the number, which means this is the frequency. Under it you have 7. Then the number of ages, which is 15 here. That's the rule. Apply the rules in all. Now you have 105. If you multiply them, that's the figure. Check very well. Now if you do all this, apply the rules, x minus mean division, just keep substituting. It gives you 0.5. This one will give you 5.25. Do it yourself. Now the ages of 16, the same rules apply. If you go like that with the table, then the ages of 18, the same rules apply. If you multiply 18 by this, it gives you 54. That's just it. Then you simply subtract mean division from the values of the number, or from the numbers or the variables. It gives you 0.25. And so on 18 is the same thing. Come to ages. The ages. Now this is the mean division where the frequency in the data is given. Okay, 20 is the same thing. That's the ages within ages of 20 years. Ages of 20. What is the frequency? How many is it? 2 times. If you multiply it, it gives you 40. That's what we have here. 40. Okay, 40. That is just it. Now every time so on and so forth. Now which means the total. You total the whole thing. Total the number of whole thing gives you 315. Okay, 300 of that is now it gives us sum of frequency is equal to 20. Okay, it's equal to 20. Okay, therefore sum of the frequency times this is equal to sum of the frequency times x. That's how you get it. Sum of the frequency. Okay, all together times x is give you 300 and see there 315. Now if you come here, it gives you that sum of the frequency divided by x, which means it gives you this. It gives you 31.5 or so. Yes, that's what it is. Now that's all for the measure of dispersion. We've just concluded by the mean deviation where the frequency data is given. Thank you very much, students, and you are welcome. I wish you all the best in your career in economics, and God bless us. Keep coming, inviting students, and God will bless you. Thank you.